Hume. Yes, folks, Hume here again. How are you going? So in this video, we're going to continue our discussion of multiples, factors, and primes. In the last video, we spoke about multiples and factors. In this video, we're going to illustrate the difference between the two by using a number that is familiar to all of us, the number 12. So let me start. What are the factors of the number 12? Well, as we did in the previous video, we start with our good friend, the number 1. So 12 is what? 1 by 12. 12 is also 2 by 6. 12 is also 3 by 4. 12 is also 4 by 3. Now you notice that we have gotten to the point where we have the order of the pairs reversing. So at that point, we know that we have all the factors that we need. The next step is to write it out. So what are the factors of 12? 1, look at there. 2, next one. 3, next one. 4, next one. All right? Now, what did we multiply the... No, let me not say that. What I would normally do in this case, since, let me just, right? I don't mind if all this team struggle a little bit. That's part of the game too. Don't let nobody fool you. So, we know that 3 by 4 and 4 by 3. We saw the order reversing. But there's also, what I would normally do when I write in factors is go right up to half if it's an even number. But 6 by 2 done here already. So the original pattern that we discussed in the previous video still holds. Because anything after 6, the next pair would be 12 by 1. At that point, you're just repeating yourself. So let us, for the sake of argument, we can leave the 6 by 2 just so that we could see 1, 2, 3, 4, and 6. But we could also erase it. All right, so there we go. 1, first factor. 2, second factor. 3, third factor. 4, fourth factor. Now the fifth factor is clearly 6. But if we had taken the position of not writing this here because we're already repeating what we have here, then we get to 4, but 4 is not half of 12. We know that 12 is an even number. So if we have an even number and we're trying to list the factors, then we have to put the half. We can't leave that out. So even if we don't write this because we don't want to be repetitive, seeing that we have the 3 by 4 and the 4 by 3, then we have the 2. We have the 6, sorry, which we get by multiplying the 2. And then, of course, we have the 12 itself, which we get by multiplying the 1. So if we have to list the factors of 12, then we have 1, 2, 3, 4, 6, which is a fifth factor, and then 12 itself, which would be, well, that's the number itself. So those are the factors of 12. So we draw a line down the middle of the board. Excuse, huh? We draw a line down the middle of the board, and on the next side of the board, we go to consider the multiples of 12. What are the multiples of 12? What numbers do we get when we multiply the number 12 by 1, by 2, by 3, whatever? All right. So the multiples of 12 are 12 by 1 is hello. Okay, right. I'm just checking my microphone. Microphone check 1, check 1, check 1, check 2. Right, we're going again. So when you multiply 12 by 1, you get 12. 12 by 1 is 12. 12 by 2 is 24. Nah, let me use the simple notation for now. We'll get to the fancy stuff later. So 12 by 1 is 12. 12 by 2 is 24. 12 by 3 is 36. 12 by 4 is 48. 1, 2, 3, 4, 5, 6. Let me use 6. 12 by 5 is 60. 12 by 6 is 72. Going on the road, etc., etc., etc. 12 7s are 84. 12 8s are 96. 12 9s are 108. 12 10s are 120. 12 11s are 132. And 12 12s are 144. If we're dealing with the back of the copybook. But for the sake of parity, seeing that we have 6 factors, I chose also to list 6 multiples. So in other words, the multiples of 12 would be 12, 24, 36, 48, 60, and 72. So the factors of 12, look at here. These are the factors. And then these are the multiples of 12. Big difference. Don't get these two confused at all. The multiples are the numbers we get when we multiply. Now, of course, with the multiples, it doesn't really end there. 72 going down the road. So there's no end to multiples because you could always multiply by the next number in the line. So if you multiply 12 by 355, then you could just multiply 12 by 356. And there you go. So the number of multiples is infinite, meaning it has no end. Or infinite. Not sure how the pronunciation goes, but you know how these things will be. Potato, potato. Potato, potato. We don't really say potato. Tomato, tomato. Tomato, tomato. Yeah, that's how more like it. One of those things that, you know. Multiples. Infinite. Never ending. Never stops. Factors, however, are finite. F for factors, F for finite. Finite, finite, whatever. Right? So in 12, we only have 6 factors. We only have 6 factors of 12. 1, 2, 3, 4, 6, and the number 12 itself. And that's basically it, you know. And you could do this with any other number that you care to choose. So let me say 15. What are the factors of 15? Factors of 15 will be 1, 2 is not a factor of 15. 3 by 5 is 15, so 3 is a factor. 5 by 3 is 15, so 3 by 5, 5 by 3, that's it. 1, 3, 5, and then the number 15 itself. So 15 only has 4 factors. 1, 3, 5, and 15. How many multiples does 15 have? 15 by 1 is 15. 15 by 2 is 30. 15 by 3 is 45. 15 by 4 is 60. 15 by 5 is 75, etc., etc., etc. There is no end to the multiples of 15. So the multiples don't really stop. So we have 12 on the board, looking nice like spice. So let me just drive home the point now by just writing on the board the same thing that we just outlined for the number 15. Right? You say it and then you write it. You wouldn't necessarily do both every time, but I try to do it as much as possible. Put as much effort as possible into explaining the stuff in the video, and then the technology allows me to do this once and put it somewhere at the beck and call of whoever interested enough to go and get it. Right? So I want to give a very special shout out to teachers from times past who would not have had access to the kind of technology that we have now. So teachers in past times would have had to repeat these things a number of times. And if you're really looking at these videos and paying attention, you will see that a certain amount of effort and energy goes into this. Right? Teachers in schools, special big up to them as well. Because in school, by very nature, you explain something to one group of students this year, and then the next year you have to explain the same thing to a new set of students. Not being in a school allows me the freedom to say it once, leave it as a recording, and then you leave it up to people to use the technology to get it. That way, I can now focus on the practice with each successive group of students. So if we talk about factors and primes today, that wouldn't change next year, you know. So with the technology, I don't have to explain myself to the next set of students next year. I just say, hey, look the video. Take your time and watch it. And after you watch the video, then we come together in the live session and we say, all right, what problems are they having? Because different groups will always have different issues. So I'll have one group of students this year, one set of issues. Different group of students next year, same content, but all kind of other stuff will come up. And that is where the learning gets really nice and fun. But to get to the fun, sometimes you have to go through the slug, the muddy part. And then when they go through the mud, they come out into the green, grassy plains where the sun's shining and the flowers smelling sweet. And they roll around in the grass and thing. But you had to go through the mud and the slug and the water and everything. And plenty things in life like that sometimes. Alright? So again, I just want to shout out the teachers from times past and the teachers in schools who would have and who have to repeat. That is something that I don't have to do. But it means that more effort is transferred onto the student. You watch the video as if you were in a class, and then when we come in the live session, we go and we go in and we go in strong. We use that time to explain and all of that. So I'll just take a few minutes to explain my methodology. Let me get back to the maths. So we finished out the video now by talking about the 15. What are the factors of 15? 15 is equal to 1 by 15, sorry. 2, no. 3, yes, 3 by 5. And you realize we have 5 by 3. So the order reversing, so we know we could stop right there. 15 is not an even number, so we don't have to consider any half of 15 as a factor. So that would be what? Factors of 15, 1, 3, 5, 15. End of discussion. Right? And then the multiples of 15, make a better 5 on that now. The multiples of 15 would be 15 by 1 is equal to 15. Right? 15 by 2 is equal to 30. Come, make a proper 3. 30. 15 by 3 is equal to 45. 15 by 4 is equal to 60. And we could go on and on. 15 by 5 is 75. 15 by 6 is 90. 15 by 7 is 105. Etc. 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 So if we had to list the factors of 15, we have 1. But look at here already. And then if we had to list the multiples of 15, it would be 15, 30, 45, 60, da. Sometimes you'll find yourself in a situation where the question will say, list the first 4 multiples of 15, or the first 6 multiples of 15, or the first 7 multiples of 15. Well then, if you have to list the first 7 multiples of 15, it doesn't multiply 15 successively by 1 to 7. 15 by 1, 15 by 2, 15 by 3, going on the road. Right? You could do that for multiples. As we have discussed in the previous videos, it's not so straightforward where the factors are concerned. And that's basically it, you know. That is basically it. So you have seen in this video an illustration of the difference between factors and multiples, not to ever be confused with each other. So you start off by considering the very words themselves. If they ask you for the multiple, then tell yourself that you have to multiply to get a multiple. If they ask for a factor, then you have to do something. We haven't used the word yet, but I will throw it in now at the end of this video. To get a factor, you have to divide. So a factor is the opposite of multiple. Alright? To get a multiple, you multiply. To get a factor, you divide. Alright? Now I went through all the procedures there without using the word divide, so that you understand how to get the factors, understand what it is, and now at the end I say, yes, what we did was divide. Right? Because we divide 12 by 1 and realize that you get a whole number, so yes, 1 is a factor. We divide 12 by 2, you get a whole number, so 2 is a factor. 12 divided by 3, etc., etc. If you had to use 15, you divide 15 by 1, always get back the same number. You divide 15 by 2, 15 by 2 will not give you a whole number. So 2 is not a factor of 15. 15 by 3, well, 15 divided by 3, sorry, is 5. So 15 is, so 3 is a factor. 3 by 5 is 15. 15 divided by 4, not a whole number, so 4 is not a factor. 15 divided by 5, whole number, 3. So 5 by 3 is 15. 5 by 3 is the same 3 by 5. Boom, you have all the factors. Nice? So many ideas to assimilate. That is why the videos are so good, because you could pause and you could stop and you could rewind. You could go to sleep tonight and wake up in the morning and continue, etc., etc. So with that, we bring an end to this particular video. In the next video, we're going to round out this series by dealing with the specific case of prime numbers. Prime numbers are very special when we're talking about multiples, factors, and primes. So look out, next video coming. Boom!